Hello everyone, I'm Sadly and I'm going to walk through the latest box titled Sussy API. This is a CTF for DoubleSec. The box is pretty straightforward. It's a boot to root style like Hack the Box. The user flag is a web app that's vulnerable to a chain of two attacks. The first attack is server-side request forgery, and then you can chain it with path traversal in order to read arbitrary files on the system. With the SSRF plus the path traversal chain, you can use that to read backups. You can read a backup containing old code, and that code contains credentials to log into the box via SSH. After SSHing onto the box, you'll find a little toy web app. It's a Python program running a Flask website, and it is vulnerable to format strings. And the weird thing about format strings in Python is if you let a user control the template that gets formatted, you can use it to read arbitrary variables. And in this case, because the OS module has been imported, the OS module is considered a global variable, and you can read that variable and essentially dump the environment variables. And the environment variables contains credentials for the root user. So that being said, let's get on with it. Let me connect to the VPN. And then let me try to ping my box. There we go. So I'm going for 10.11.12.13, and the first thing I want to do is an Nmap scan. So I'll create a directory called Nmap. I'll seed into Nmap, then I can run my scan. Nmap tac-sc for default scripts, tac-sv for default versions, tac-v-tac for all ports, tac-t5 for an aggressive scan, and then tac-v for verbose, tac-oa for all formats, and then the IP address of 10.11.12.13, or sorry, .3. And this is probably going to take a while. I put the IP address in the wrong spot. It goes 10.11.12.3. Tac OA sussy API. And there we go. That should do it. I discovered an open port 80, open port 22. So let's go check out port 80 since that is likely to be a web app, and port 22 is likely to be SSH. Looks like 82 and 81 are also there, but for now, let's just check out 80 and 22. Oh, Nmap scan's already completed. Let's look at the normal version. Okay, there we go. So the script's done. Port 22 got SSH, pretty typical. Port 80 is an Nginx web app titled Sadly Sussy Site. Then we have ports 81 and 82 open. Both are also running Nginx. The web app on port 81 doesn't actually have a title, and the web app on port 82 is forbidden. We can't read it, so we'll probably have to figure something out later. For now, let's visit port 80 since that looks a little bit more interesting. It actually has a title. And there we go. Sadly Sussy Site, and this is the first flag freebie. Are there any links on here on these buttons? No, nothing. What about this button? It brings us to a /chat, and it tells us that the API front end is cursed, and there's nothing much I can actually do on here. This website is just dead. There's nothing on this page, technically. And I don't know any other endpoints. So to scan for other endpoints, I'm going to do a forced browsing attack using a tool like Pharaohbuster. So I'm going to create a directory called Pharaoh, just for, organization. Then I can run Pharaoh Buster, attack H, because I don't actually remember how to use this thing off the top of my head. So I'll use, let's see, Pharaoh Buster, attack U. I'm going to specify this site. I am going to specify a word list. How do I specify a word list here? Tac W. So tac W, user share word sec lists, web. Oh, not that. Discovery. There we go. Web content. I'm looking for wrapped large words. So wrapped large words dot text. I want to save the output to wrapped large words dot Pharaoh. And I don't want to scan recursively for now. So how do I do that? Recursive. Oh, tac N for no recursion. So let's try that. And let's see, pretty quickly, 200 for slash, okay, 200 for slash chat, we already found that, and 200 for slash front end. Okay, cool. Slash front end was found, and it looks like it's just a site with one button. Let's click that, and it's just this dumb looking cat. Not much to see here. If we press the button, it looks like it just gives us a random image. So I want to see how that works. I'm going to open this up in Burp Suite, so I'll go to proxy and I'll open the browser. I'll see if this actually runs. Okay, 10. Nope. 10.11.12.3 slash frontend. And if I press the button, we get a post request. So pressing the button sends a post request to slash frontend. That's pretty typical. What does this button actually do if I inspect element? And sure enough, it's a button with a name of Sussy API, and the value is this URL. So when I press the button, it just makes this post request, and the response looks something like this. If it ends up loading. Yep, so press the button, sends this request. This looks familiar, Sussy API, and the value is this URL. That matches up with what we saw right here in the inspect element. Let's see if we can play with this some more. I'll just send this to the repeater, and this value I'll go check out in a web browser. So localhost 81/API. So I'll paste that in, but I don't actually have something running on my localhost. So this has to be 10.11.12.3 :81/API, and it looks like it just gives us a random image, just like we expected from the normal API. So we go back to the repeater and we make this request. Let's render it. And it's just this image. If we look at the pretty version, we know that this image of the cat with the gun is going to be, just from reading the HTML, it's probably going to be in this image tag. And the source of this image is in uploads. So I'll copy this, and I'll visit port 80, but I'll set this to the uploads directory. And sure enough, it is the same image as we got over here. So, in a nutshell, what we've gathered info about is the slash front end has a button that accepts a parameter of URL. And what we can safely assume is that the URL probably makes some sort of request to this URL and saves the information it got, or in this case, it saves a photo from this URL into this slash uploads directory. This would be useful in like a server-side request forgery attack if we want the server to make a request for us, because this is obviously making a request to localhost port 81/API. We haven't checked out port 82 yet, if I remember correctly. So if I cd into nmap and I'll cat the nmap scan. So we checked out port 80, 81, which has the API, and we have to go check out port 82 now. So if I look at 10.11.12.3, port 82, it looks like it's forbidden. We can't actually see the contents of the site, but it might be able to be visible from the target we're trying to attack, the 10.11.12.3 machine. And we can test this by, instead of making a request to port 81, let's try and make the server make a request to localhost on port 82. So I changed this to localhost port 82. If I try to render it, there is no image here. And if I look at the uploads, if I look at what was uploaded, then we should be able to see what the server found on port 82. And this is what it got. Chat logs for internal use only. So for internal use only makes me think, okay, this is probably only visible by localhost, which makes sense. We, the attacker, weren't able to see it from our own machine because it was, we saw it was 403 forbidden. But once the internal machine saw it, the 10.11.12.3 machine made the request instead, it worked just fine. So we can retrieve old logs with /logs and then the name of a file. So let's try copy this and add this to the end of our request. So this URL is localhost port 82 on the /logs endpoint with a file parameter, and the value is 0.txt. Let's copy this. Throw this in our URL. And it looks like, a text file. In particular, this was 0.txt. It shows logs of a chat. And if we read through this, Tayari asks Sadly if they used hard-coded credentials, and Sadly reveals that this particular old version is located in /var/backup/api.tar.gunzip. So it's important to read through this log because you'll want to find the location of this file. So that's important. What other files were there? There's 1.txt, which we can check out later, but there was also foothold.flag. So if we replace this, So if we replace this with foothold.flag, we can check this out. let's just use curl here. So I'll curl HTTP 10.11.12.3 port 80. And this is the flag. The second flag, the foothold. Let's try something else. What if I did something like // password? I use // password because this is a world readable file in Linux. So I'll copy this and let's see if that works. And there we go. We successfully did a path traversal attack. So the first one was server-side request forgery, where we put in the location of an internal resource, in our case, port 82. And the // is path traversal. So we were able to go up to the parent path because in Linux, if I do something like lstack-l, or lstack-la actually, dot means the current directory and dot is the parent directory. So here, // all the way up to the root directory /etc/password gets us the file, /etc password. So that's what that attack is, and it worked. Let's try to find users with shells because this is a whole lot of gobbledygook nonsense. So I'll grep lines that end with sh. Looks like I need to run it again. Rep sh. I need to put the new uploads file here. There we go. So there's only 2 users with shells, root and satellite. If we remember from this chat log, there is a file containing backups. So I'm going to copy this and put this over here. I'll make that request. Copy that. And then now I can curl it. So I'll curl HTTP 10.11.12.3 port 80 /uploads. It's a binary file, so I need to specify tac output. And the name of the file is api.tar.gz. It's taking a while to download. Looks like it's done. I can check the file type, and it is in fact a gunzip compressed file. So I can extract it with tar xvf api.tar.gz, and it looks like we got an API directory. So I'll cd into API, cd into API, there we go, and it looks like a program written in Go. So let's try a look at api.go because these are just Golang project files. This looks like a binary. Let's read this main file. So I'll cat api.go. So yep, this is a main function, typical Golang project, and it looks like we have some basic auth of a username called Sally and a password of whatever this stuff is. So that's neat. If I remember from checking out // password, there is in fact a username Sadly on the box. So let's see if I can use this password and SSH. And if we remember, SSH is in fact on the box and it's running. So I can simply, try SSH Sadly at 10.11.12.3. I'm getting prompted for a password, which should be this value right here. I'll paste that. and I'm logged in. And I can cat user.flag, and we got the flag for user. So next up, I want to go for the root flag. I can maybe sudo tacl. It asks me for my password, so I'll enter my password, but I'm not allowed to run sudo. I'll list the running ports, netstat, tac tulpen. Maybe I don't want U because I don't care about UDP for now. I'll just look at TCP ports. There we go. So .11 I don't really care about, but these localhost ports look cool. I know what these are. So these are the exposed ports that I saw earlier. Port 22 is SSH, and then port 80, 81, and 82 are the web apps running. This was Sussy Chat, this was the Sussy API, and this was the logs server, the one that was forbidden. And if we investigate further, we'll actually just find out that 7001, 2, and 3 just get mapped to 80, 81, and 82. We can confirm this if we go into the Nginx logs. And by the way, I know it's Nginx because Nmap told me that it was Nginx. So I can cd into etc Nginx. I can cat sites available /default to view the default Nginx configurations or whatever was configured. In our case, we see that port 80 has a reverse proxy pointing to 7001. 81 has a reverse proxy pointing to 70,002. And then Nginx has a reverse proxy that directs 7003, that directs 82 to 7003. So that's what these are. You'll notice that this one looks pretty special. Port 5000 is open. We haven't seen that one before. And if we look at the running processes, which I haven't shown you yet, these are a bunch of programs. So the API is, probably the one that's sending us random images. The logger was the forbidden page sending us logs. Sussy Chat was probably the main site, and we can actually, go through the code on the server and confirm it. And there's also this login portal.py. We can search for this file pretty easily with a find command. So we can find any file in the root directory with the name of login portal.py. We'll send errors to dev null, and there we go. /var/www login portal /login portal.py. So if we go to /var www login portal, login portal.py is right there. And I should mention, when I saw login portal.py, you should note that it is running as the root user, which is pretty interesting. If I read the context of login portal.py, it is a simple Flask application running on probably the default port of 5000. So if I curl localhost 5000, I get what was in the login portal.py script. Because, I can tell I just made a GET request to localhost 5000, and I got, hello, please submit your username and password. Just like this, hello, please submit your username and password, example, and I got this. So I know that this Python code is running on port 5000. Let's read some more. So it's a Flask application. I have a class of user as a name and a password. There is a string representation for the user. If the user's name is admin and the password is the secret environment variable, then we'll print welcome admin. Otherwise, we'll print that we're a temporary user.
And here are the routes. If I make a post request, then it creates a user, and then it'll greet the user. If it's a GET request, then it sends the message that we already saw. So let's try this post request. So I'll curl techx post to localhost 5000. And the data I'm sending is a username and password, as seen here. So let's see, username equals Sadly, and the password equals super secret. And logging into Sadly, I am a temporary user. Okay, cool. Let's read the code again, because as we see, there's a comment telling us that format strings shouldn't be used in Python anymore. It's because they're giving us a greeting, and then it puts in a name, and then it throws in the user. So this greeting is kind of a template of sorts, and then we format the greeting. So it's a simple format string. And this was pretty common in Python 2, still available in Python 3, but it shouldn't be used anymore because it's vulnerable. If we use our, oh, there we go. If we use our best friend Google to search for Python format string exploit, let's try and read the first one. See if it gives us anything good. See if it actually loads. See if my internet connection is any good. Okay, there we go. Format strings, you can read this blog, but basically what happens is that if we let the user control what goes inside the template that gets formatted, we can read arbitrary variables through the globals. So as you can see, what actually gets formatted? So is this even a good example? Let's see. Oh yeah, here we go. Template, and it gets formatted. And so the template is argv1 or argv2. So render HTML. Yeah, so it's argv1 that gets rendered. This is not a good example. Let me try the Geeks for Geeks article. Maybe this will be a better example. Okay, there we go. Oh my goodness, it's in light mode. Oh, there we go. It's in dark mode. That's better. Okay, let's see if I do the object, we can search for the init function, and it uses the people object right here because that's what's getting formatted. So we have some user-controlled string. Get out of here. We have some user-controlled string. It gets formatted, and whatever is inside the string with the curly braces with people object, we set it to a variable called people object. In our case, the stuff inside the curly braces is user, and we format it with user. So that means we have to use user. Let me show you what I mean. So essentially, you can figure out that we can make a curl request, but we can set our username to user. And, oops. Let me try that again. And if I specify the init method, this is interesting. Logging in as bound method user of welcome user, you're a temporary user. That's really weird looking. If we look back here, I can get all the global variables or all the variables visible in the current scope. So let me add the globals. And here we go. It is a dictionary containing all of the variables visible to this user variable. For example, I have name, which is main. So if I were to do underscore name, I should get the string main back. Or not. Oh. It's because globals is a dictionary, so I have to use name. There we go. And it gave me main back, which is what we expected. Doc is none, package is none, loader is this weird loader thing. And if we look through, there is a value of OS, and it's a module. That's interesting. I wonder if we can see what's inside of it. So if I do user.init.globals with the key of OS, I get back the module, which is what I expected since it matches up right here. Now I can do something like os.system, which is a function, but that doesn't help me because I can't actually call code and I can't specify parameters, but I can specify what was in the code, which is the variable called environ. This isn't a method, it's just a variable, which is perfect for our situation because we can only read variables, but we can't call or execute code. So let me type the whole thing out because this is probably the solution. So I'll curl tech post to send a post request to localhost port 5000. I'll send the data of username equals, and then I'll put my exploit here, and then the password equals, I don't know, foobar baz. We don't care. We don't care. And in here goes the format strings template of user, because the user is actually getting substituted. I specify the init method, and I can specify the globals, because .init.globals gives me a dictionary of all the variables that are in scope. I can grab the key OS, which will return the OS module, and I can read the environ. So this dumps all the environment variables. For example, the host name is OB5 blah blah blah, which is accurate. On the current working directory is, var login portal. The home is root, so that's interesting because the login portal is actually running as root and blah 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 blah. But basically, what we wanted is this secret, because this secret was the admin password. If we specify this password of equals admin, and then the password is this thing over here, we get logging in as admin, welcome admin. It also happens that this is a password, so you should think to yourself, oh, maybe I can log in as root. So I'll sudo tac-I, and I can't log in as sadly, so instead I'll use su to log in as root. I'm using this password, I'll copy that, paste, and now I'm root. Who am I? Root, ID 0. I can go to the root users directory and cat root.flag. And there we go. That's the last flag. So yeah, that was a pretty straightforward box. Hopefully you learned something. To recap, the user flag was a chain of vulnerabilities, specifically SSRF, or server-side request forgery, chained with path traversal, which let us read arbitrary files on the system, particularly a backups file. The backups file revealed hard-coded credentials, which let us SSH onto the box. Then once we were SSH'd onto the box as the user sadly, we were able to view an internal Flask web application written in Python And the Python website had a format strings vulnerability that let us read arbitrary variables, including environment variables. And this environment variable contained a password for root. And that's how we got root on the box. Thanks for watching, and hope you had fun with the CTF.